Hello and welcome to part 2 of our chapter 3 video. Notice that there's a second document you need to acquire from from Blackboard, that is Word, that has some different notes, and we're also dealing with a new set of data here. So our data is about the height of individuals and inches and whether or not they are male or female. So what's distinct about this data set compared to the previous one is that we do have a quantitative variable here, and then we additionally have this categorical variable that groups my quantitative variable into two groups by gender, male or female. Sorry, sex, not gender. Anyway, so since we have this data already open, if you don't and you want to follow along, you might want to do so now. We are first going to create a histogram of just the height variable, so ignoring the fact that I have this additional bit of characteristics about all of my individuals in my data set, or cases. So, to create a histogram, we need to be, I'm already on the graph menu, oops. So you need to hit the graph tab, and then go over to histogram and select simple. Notice there are some other, I wanted to show you the options here. So notice it says single y variable, that's because I'm looking at a single quantitative variable here, and that's why I want single y variable and simple. And I want to put height in there. I'm going to go ahead and hit OK. This is just the default version. And so there's the height variable all by itself. I'm going to make this just a little bigger so you can see it. Hold on. Ooh, there we go. So as you look at this variable, this graph, you might try to describe its characteristics. Like the center looks to maybe be about, 68, maybe a little bit lower than that, I would say, like maybe 67.5 or something. And then if you were to describe its spread, you could do its range, or in general, it looks fairly symmetric. But if you go to describe the modality of this graph, I'm hoping you notice it looks like it has two peaks, one distinct peak over here and one distinct peak over here, which means this is actually bimodal instead of unimodal. You might make the mistake of thinking, oh, well, this is the center, so that must be where the peaks are. That's not necessarily true. Remember, modality is about I am the tallest bar relative to the bars that are nearby me, not necessarily where the center of the graph is. So there is our histogram, which I'm going to copy over to my Word document. Here we go. The next thing I'm going to do is I'm going to start grouping. So now I want to create a histogram for the variable height, but grouped by gender. So to do that, we go back to histogram, and notice I still want to choose single y variable, so one variable that I'm looking at that's quantitative, because I am just looking at one height. And then I'm going to split it into two groups. Now, this is different from the multiple values of y simple, which is where you have multiple quantitative variables that you want to sit next to each other, where ours is distinctly different from that. So we want with groups. Okay, so I'm going to put the height variable in there, and then the sex variable. And if I remember correctly, I do not like the way this looks, but we're going to hit OK and hope it's going to be okay. Haha! I like it better when it color codes these. Anyway, so as you look at these two, it's done a couple things that I do like. It's made sure that my scale is the same, so all my bins are the same size with this type of histogram. So I noticed that because, this goes down to 52 for the female, but there's no males in that range. And it goes up to 80s for the females, and there's definitely males in that range, but no females. So it's covering the range to make sure that I go through all the possible values for both genders. And I'm hoping that you notice that, hey, I do in fact have two distinct groupings here, and they have a little bit of different behavior, because notice the center for males appears to be, about, I would say, 70, and the center for females is probably about 63. Now, I'm going to mess with the settings for this for a little bit, if I can. I want to change how it groups this. I don't think it's going to let me. Nah, it's not going to let me. Okay. If you watch the 17 video, I did an overlay of these two where you can see, yes, here's the female group overlaying with the male and how it relates to the previous histogram. But this is good enough to see that, yes, the two distinct groups, when overlaid together, look like they're the same, but when you look at them separately, clearly they are not. Here we go. And then we're going to create a box plot of this. This will be useful in comparison because, we can do the quick version like we just did where it's the center, but then it's really hard to tell the spread. The best you can do is the range. The IQR is far better than just the range as far as detail goes, so let's make ourselves a box plot with two groups. So since I'm still dealing with a single y variable, just height, I want single y variable with groups. So I'm going to put in my y variable, my height, and then my groupings. You actually can do multiple groupings in here, so notice this box is bigger. I only have two variables, so I'm not doing that. I like it better when it color codes them. Anyway, so as you will notice, the centers are much clearer. Sorry, the difference between the centers is much clearer here. So you notice the median is 69.3, and here it is 63.9. It's funny that those are a transposition of each other in just one digit. So on average, your females are about 6 inches shorter. That seems kind of large. Oh well, it's a little smaller than that. Anyway, so the other thing you can notice is how the quartiles overlap. Like, oh, well, the middle 50% of women are on average shorter than men because look at where the median lies. It lies above this center box for the females. And we have a couple outliers for males, and those are all on the shorter end of things. And notice that the female and the male box plot are both fairly symmetric, which is kind of interesting. So let's copy this and paste it. And again, I'm just estimating the difference here by saying, look, it looks like they're about 6 inches apart. That doesn't mean that that's definitely how far apart they are. Go ahead and enter. Let's calculate the mean and standard deviation for the height variable. So over here I was comparing the median and looking at the quartiles. So to compare the mean and standard deviation, I really should actually calculate those. So we're going to go to statistics, describe, and I want to do descriptive statistics. And I'm going to look at the height variable grouped by gender. The next thing I need to do, so this is going to do the height variable, but it's going to split it into the two groups, male and female. And I'm going to hit the statistics button because I want to make sure it knows to only do the mean and standard deviation, and I don't need any of the rest of these, so I'm going to uncheck those real quick. Then we'll hit OK, and it should produce our two separate groups. So notice it makes note, oh, I'm doing height, but I'm separating it by gender so that I have all of these. Let's copy this and paste it into our document. And one of these things that's interesting about this is it does kind of give you what you were expecting. Okay, yes, on average, it's about 5 inches, so slightly smaller than what the median was showing. Oh, excuse me. But when I consider spread, they're spread out about the same. So yeah, they look very similar in shape, they look very similar in spread, but one, it looks to be larger than the other. So it's almost like to get the male graph, you picked up the female graph and moved it over 5 inches. They look that similar, which makes sense with what we were observing. Cool. Oh no. I did number 5 first. Alright, so since I screwed up, I got too excited. It's fine. I'm just gonna hit undo and paste that for number 6. So I did number 6. Let's do number 5, because I do want to compare number 5 and number 6, which is what I meant to do. Describe, descriptive. Normally what I would do in this situation is just delete this, re-record 5 and 6, and then, oops, I did it again because I'm not paying attention, and then let you guys not think I'm like absolutely epically perfect at this. That's so rude. Anyway, I'm not. Here we go. So there's it for just height. What I really want you to notice as you look at this is that when you look at the mean, you might think, oh, well, if this is just including all of them, shouldn't it just be the average of these two? Well, what's halfway between 4 and 9? So you might look at this and be like, okay, so halfway between 4 and 9, that should be about 66, probably a little bit smaller than that, since this is 0.2 and 0.4. And this comes out as 67, because when you look at this sample, I might have more males than females, or I might have more short males or more short females, or, you know, more tall females than I do males that are short, in which case this mean is affected by size, not necessarily what the previous means are. Another thing to notice is the standard deviation got bigger because I'm looking at more values that are spread away from the mean. And we'll talk about when I look at combining variables. This won't happen until chapter 7, so it's going to be a while. We'll talk about looking at how the standard deviation gets really messed up when you try to combine two variables. So notice it's not just, hey, this standard deviation will be the same since it came from both these groups. And it's not the average of these two just because I have these two groups separated from that. So that's a common misconception. That's all I have for you today. Thank you for your time and attention.